Okay, what we want to do now is learn some basic rules for finding the derivative or the slope of the tangent line or the slope of the curve at a point, because we don't want to use that long limit definition that we learned previously. A couple of the general rules is, the first one is what's called a constant rule. But a constant is just a number. Like if I give you y equals 4 and I ask you what's the slope, this is just a horizontal line, so the derivative, or y prime in this case, would be 0, because the slope of a horizontal line is always 0. So the slope of any number by a constant will always be 0. The next one is the one that you're going to be using the most often. It's called the power rule. So if you have a function like y equals x to the 5th, so you have x raised to a power, the derivative, the rule for it is you bring down the power and reduce the power by 1. So the derivative of x to the 4th is y prime is equal to 5x to the 4th. You would get the exact same answer if you use that entire long definition with the limit. Now, a couple other properties that we have is what's called the constant multiple rule. That just means, what if you have a number, a constant multiple, in front of the function? So instead of y equals x to the 5th, let's say I have a number in front. Then you take the derivative using the power rule like we did before. So the derivative of x to the 5th is 5x to the 4th. And the number in front, you just go ahead and multiply with it afterwards. So really your answer is 15x to the 4th. The next property is when you are adding and subtracting. When you are adding and subtracting terms, you just do each term separately. So if the function is, let's say, y equals x squared plus x cubed, you just take the derivative of each term separately. So the derivative of x squared would be 2x, bring down the power, reduce the power by 1. And then x cubed would be the same thing. Bring down the power, reduce the power by 1. And the last two are going to be some trig derivatives that we're going to start learning. The derivative of the sine is cosine, and the derivative of the cosine is going to be negative sine. So let's look at a couple problems using some of these properties and rules. One thing to keep in mind is sometimes you may have to rewrite the problem before you actually apply the rule. Okay, the first one, I just have 3 terms. I'm going to just do each one separately. The derivative of 3x squared is I'm going to bring down the power, multiply by the 3, so it's 6x. The derivative of 4x is just 4. Really, if you bring down the power, which is 1, reduce the power, it's 4x to the 0, so it's just 4 by itself. And remember, the derivative of constant is just 0. So your final answer is just 6x plus 4. The next one, remember, square root of x is really x to the 1/2. I would rewrite that. So using the power rule again, bring down the 1/2, reduce the power by 1. And for right now, you can leave your answer like this. If you do want to simplify it, really the exponent goes to the bottom. The next one, that 6 on the bottom is really the same as this. Pull out that 6 and let's rewrite it like this. So you can really think of it as that constant multiple, right? So what do? We just multiply. So we're going to leave that 1/6. The derivative of x squared is 2x. And the derivative of 3x is 3. Anytime you have x's on the bottom, you can only use the power rule if you have x raised to a power. So I need to rewrite this like this, as 9/5 x to the -2, and now I can use the power rule. So I'm going to bring down the -2, multiply by that coefficient, reduce the power by 1. If you wanted to simplify it, all you have to do is put that x on the bottom and it becomes a positive exponent. Now the next problem is what's called a composite function. Right? You have a linear function that's getting squared. So we don't know how to work with composite functions yet. So what you will have to do is multiply this out, which becomes 9x squared minus 6x plus 1. Then we can go ahead and take the derivative. So f prime of x is going to give me 18x minus 6. The next one is a quotient. You cannot take the derivative of the top and the bottom separately and just divide it. There is actually a different quotient rule that we're going to learn later. But for right now, what we're going to do is rewrite this. So think of this like this. This is the same as this, right? We can take each term on the top and divide both of them by x squared, which really means that the first term is really 4x cubed, and I need to rewrite the second one like this as x to the negative 2 so I can use my power rule. So step 1 is to rewrite it, and then let's go ahead and take the derivative. So bring down the power, reduce the power by 1. The next one, if I bring down the power, it becomes a positive 2, reduce the power by 1. Okay. At this point, try the last 6 on your own, and then you could check it against my answer key that is posted.